Have you ever pondered the origins of the universe and what possibly could have existed before the Big Bang? It's a question that nudges at our innate curiosity, a question that has been a focal point for scientists and thinkers for generations. Let's take a step back, about 13.8 billion years. Picture this. The universe as we know it began from an extremely hot and dense point. This point, unimaginably small and infinitely dense, contained all the matter and energy that would eventually form galaxies, stars, planets, and, yes, even us. This is the essence of the Big Bang theory. But this wasn't a bang in the traditional sense. There were no explosive sounds reverberating through space. Instead, it was an expansion, a rapid stretching of space-time itself. From that tiny, dense point, the universe began to grow, to cool, and to take the shape we recognize today. And it hasn't stopped yet. The universe continues to expand, even as we speak. Now you might wonder, how do we know all this? Well, the universe itself has left us clues. When we look at distant galaxies, we notice something peculiar. They're moving away from us, and not only are they moving away, but the farther they are, the faster they're going. This phenomenon, known as redshift, is a compelling piece of evidence that supports the Big Bang theory. And then, there's the cosmic microwave background radiation. This is the afterglow of the Big Bang, a relic from the universe's fiery birth. It's like the universe's baby picture, imprinted on the sky, and it offers us a snapshot of the universe, as it was roughly 380,000 years after its birth. Together, these pieces of evidence paint a compelling picture of a universe born from a hot, dense point and expanding ever since. But if the Big Bang marked the birth of our universe, what was there before it? Before the Big Bang, there was what exactly? This simple question opens a Pandora's box of cosmic conundrums. The Big Bang theory, the most widely accepted explanation of our universe's birth, provides us with a solid understanding of the universe from a fraction of a second after the event. However, it leaves us in the dark about what preceded this monumental explosion. Here's where things get tricky. We're bound by our current understanding of physics, which, despite its impressive strides, still struggles to peer beyond the Big Bang's event horizon. Digging deeper into the past, we bump into an impenetrable wall, a singularity where all known laws of physics break down. It's like trying to look beyond the edge of a map where "Here be dragons" is scribbled. In our everyday lives, we're used to the linear flow of time, always moving from the past, through the present, into the future. But what if I told you that this concept of time might not have existed before the Big Bang? Yes, it's a mind-boggling idea. Time, as we understand it, is intrinsically linked with the fabric of our universe. So if our universe began with the Big Bang, it's plausible that time itself was born in that fiery crucible. This notion throws a wrench into our initial question. If there was no time before the Big Bang, then the concept of before itself becomes meaningless. Can we even talk about something existing before if there was no time for anything to exist in? It's a loop of cosmic proportions, a conundrum that's both fascinating and frustrating. So, could something else have existed before the Big Bang? Let's delve into some intriguing theories. The answer isn't simple, and it's shrouded in a mist of uncertainty. But one thing is for sure, it's a question that continues to challenge our understanding of the universe and keeps the flame of curiosity burning bright. It's a testament to the fact that our quest for knowledge is far from over. Scientists have proposed a plethora of theories to explain what might have existed before the Big Bang. Some of these theories are as mind-bending as they are fascinating, pushing the boundaries of our comprehension and inviting us to ponder the unfathomable depths of cosmic existence. One such theory is the cyclic model. This model suggests that our universe is akin to a phoenix, undergoing endless cycles of death and rebirth. In this scenario, the universe expands, as it is currently doing, then eventually contracts back into a singularity, only to explode once more in a new Big Bang. This cycle of expansion and contraction, birth and death, could have been happening for eternity, making our universe just one of an infinite series of universes. Then there's the concept of a multiverse, a theory that suggests our universe is not alone. Instead, it's just one of an infinite number of universes, each with its own laws of physics. Some may be similar to our own, while others could be entirely alien in their construction. If the multiverse theory holds true, then the Big Bang was not the birth of everything, but rather the birth of just one universe in an infinite cosmic ocean. Another theory that attempts to grapple with the pre-Big Bang question involves quantum gravity. In simple terms, quantum gravity is a theoretical framework that seeks to reconcile the principles of quantum mechanics with those of general relativity. According to some interpretations, quantum gravity could lead to a timeless universe. This means that time, as we understand it, did not exist before the Big Bang. Instead, there was a state of timeless quantum gravity, a sort of before time, that is incredibly difficult for our time-bound minds to comprehend. And let's not forget the theory of eternal inflation. This suggests that our universe is merely a bubble in an ever-expanding cosmic foam. In this scenario, the Big Bang was not a unique event, but rather one of countless inflationary events happening throughout eternity. These theories may seem abstract and complex, and they are. They push our understanding of reality to its limits and beyond. They challenge our perceptions and force us to consider ideas that are almost beyond comprehension. But they also represent our best efforts to unravel the cosmic mystery of what came before the Big Bang. They are testament to the human spirit, to our innate curiosity, and to our relentless quest for knowledge. These theories may seem abstract and complex, but they represent our best efforts to understand the origins of everything. Our journey into the past has led us to more questions than answers. However, we stand on the brink of a future ripe with possibilities for cosmic exploration. Our understanding of the universe's origins may soon be revolutionized by a new wave of technological advancements and observations. Imagine a world where our telescopes are not just sophisticated pieces of glass and metal, but are as intricate as the human eye, capable of perceiving the universe in ways we can barely comprehend. Picture advanced spacecraft, journeying into the farthest reaches of space, gathering data that could unlock the secrets of the cosmos. These are not mere flights of fancy, but the reality we are steadily moving towards. In the coming years, a new generation of missions and telescopes will take to the stars. For instance, the James Webb Space Telescope, a successor to the Hubble, is set to launch soon. It's designed to peer back even further in time, observing the universe just hundreds of millions of years after the Big Bang. This could provide crucial data about the early universe and potentially reveal clues about what came before. In addition, the European Space Agency's LISA mission, set to launch in the next decade, will detect gravitational waves from supermassive black holes. These ripples in spacetime could hold the keys to understanding the universe's earliest moments. Furthermore, we are also exploring the use of quantum computing and artificial intelligence to unravel the complex mathematical models that underpin our understanding of the universe. These technologies could significantly accelerate our progress in solving the cosmic conundrum. It's an exciting time to be alive, wouldn't you say? We're on the cusp of a new era in cosmic exploration, where every discovery brings us one step closer to answering the biggest questions of all. As we continue to push the boundaries of our knowledge, we inch closer to understanding the cosmic conundrum, what existed before the Big Bang. Today, we've journeyed back in time to explore the enigma of pre-Big Bang existence. We've delved into the birth of our universe, a cosmic event of unimaginable power and scale, known as the Big Bang. Yet, the question that tickles our curiosity is what was before this colossal explosion. This conundrum, it seems, is as vast as the cosmos itself. We've explored various theories that strive to explain this cosmic puzzle. Some suggest an eternal universe. Others propose a cycling universe, and yet others speculate about a multiverse. Each theory, each idea adds another layer to our understanding, yet the enigma remains. Looking ahead, we've also discussed how the future of cosmic exploration holds the promise of new discoveries. As technology evolves and our understanding deepens, we inch closer to unraveling the secrets of the cosmos. The question of what existed before the Big Bang remains a mystery, but it's a mystery that continues to drive us forward in our quest to understand the universe.